and the mean of response variable is this, and the standard deviation of response variable is that, and the coefficient of correlation is given. So they are given the data to make sure they know how to substitute. It's not really a big question, but for some reason they don't. It's the mostly fair question. Well, I don't know about this set, but so that's why I want to make sure I do it. Okay, so what we do is we are given the formula though. So I will actually pull this formula up right now. If you go to section 4.2 PowerPoint, and you go to slide 42, you see that the formula for the predicted y is equal to b1 for slope and x, b1x plus b0. Okay, so where b1 is equal to, and it's actually explained, b1 is equal to coefficient of correlation multiplied by standard deviation of y over standard deviation of x. Okay, so the formula is given, and also the slope. The slope is b1, and then the y-intercept is the mean. Y-intercept is the mean of y minus the slope times mean of x. So anytime they are given to calculate, all they need is substitute, because they're given everything. So just substitute into the formula. So I'm just going to go to that question again. So I'm going to bring that question in the practice test, and we make sure that we calculate it so they know they can do it. I want to actually use let me use my whiteboard. Okay, it's part of my whiteboard. One thing we know we are given is that the predicted equation y hat is equal to the slope of the predicted equation multiplied by x plus the y-intercept of the predicted equation. Also, that's what we're going to calculate, where b1 is the coefficient of correlation, which they know how to calculate, but it is given to them anyway. Okay, coefficient of correlation. Don't do this. All right, so now I have to write it again. So R multiplied by, I'm going to clear this. It keeps making all this mess. Making a mess. Confirm, clear that. I'm going to start over. I will start over. I don't know why this is giving me unnecessary. Okay, so y hat is equal to b1. b1 multiplied by x plus b0, where b0 is the y-intercept of the predicted. And so to calculate b1, to calculate the slope is equal to coefficient of correlation given to us multiplied by standard deviation of y divided by standard deviation of x. They are all given. They are all given. So it's not even, it's just substitution. So it's not a big deal because it's just substitution. Also, the y-intercept b0, we are told to calculate that. And the y-intercept is the slope of the response variable minus the slope of the predicted equation multiplied by x bar, and x bar is the slope of the response variable, all given to us, all given. So it's really not a big deal. So what we're going to do is go figure out where all these numbers are and plug them in the equation. Ordinary substitution. But most students see the formula and they run away. But it's not even a big deal. So let's do the substitution now. So let's do the substitution. So what are we given? I'm going to put down. So we are given x bar. So put them in the equation. So we are given x bar. We are given s of x. We are given. So we are going to. Let me actually get a picture of that question. So we are trying to answer B part of the question. So using the formula I just brought down, so we want to answer B part of this question. How do we answer B part of that question? So what I'm going to do is plug them in one by one, and then simplify. So plug in all the givens and simplify and take it easy. So they just need to know where the formula is. Okay, so I'm going to first of all calculate B1. So B1 is R times, so let me look for where they give us R. So they gave us R as negative, B1 is equal to negative 0.9. This is negative 0.9 negative. I don't know why this is. All right. I'm going to get you again out of this place. Keeps standing on my way. All right. So negative B1, we have to negative 0.9. What is my, okay, negative 9411. 9411. That is the value. 9411 is what I'm supposed to be writing here. 9411. All right. And so I'm writing B1, and B1 is the formula we are given is multiplied by standard deviation of y. So I'm just going to get standard deviation of y, and it is given to me. So standard deviation of S of y is 1.7268. So 1.7268. 1.7268. And I'm going to divide this by standard deviation of x, and standard deviation of x is given to me also, and that is 2.2583. 2.2583. And by the way, standard deviation cannot be negative. So, and if anybody calculates standard deviation is negative, something is wrong. Okay, now we're going to calculate B1. And all we need to do is put this in our calculator and get the value of B1. It's known now B1 should be negative because negative is multiplying that. Okay, so all we have to do is put it in our calculator and get the value of B1. So let's put it in our calculator and get the value of B1. I'm just going to pull my calculator up. I did not pull it up before, so let me pull it up. All right, so I'm just going to get it there. I'll get it. I don't know. I thought school. I'll be slowly moving. B1 trying to also pull up my calculator. Okay, finally it's up. All right, so I want to put in what I have in my whiteboard here. So the value of the B1 that I'm looking for, I'm going to calculate standard deviation of Y or standard deviation of X. So I have 1.7268 divided by 2.2583, 2.2583, and I get an answer. Then I get this answer multiplied by R given to me. R is negative 0.9411 multiplied by negative 0.9411. So whatever the answer I get, it is the slope of the predicted equation. So the slope of the predicted equation is negative, that is B1 is equal to negative 0.7. So the next one I want to calculate is B0. So, and we know that B0 is given to us. This is B0. And B0 is the slope of the Y. And what is Y? Y bar. Y bar is the mean of the response variable. So we look for it. It's given to us anyway. It's given to us. So I'm going to look for that in that equation. And I have that equation right here. So what is my Y bar? Y bar is 4.1833. So B0 is equal to 4.1833. All right. So I have to subtract the B1 that I calculated. So there's a subtraction in the B1 in this right here, but B1 also has a negative. So negative is going to be positive. So now I have 0.7, 0.7. So I have 0.7 multiply, come on, oh, this argument you're giving me. All right, so multiply 0.7 multiply what is my X bar, and the X bar is given to me also. And what is that X bar? X bar is 3.5, so multiply by 3.5. So I'll catch my calculator. When I simplify this, I'll get the value of the slope of the predicted equation. So this question scares students, but it actually is one of the easiest questions in the test. And it's always in the test. It's a way of checking to see that the students understand, or they can do some substitution, ordinary substitution. All right, so now I'm going to calculate the B0, which is the slope of the predicted equation. And now I have 4.1833 plus. And by the way, I can put this plus and put parentheses because I see that I'm multiplying. So parentheses of B1, and what is my answer for B1? B1 is 0.7. You know, I want to make sure that, okay, 7 times 3. I already have that there. So 0.7 times 3, 5.7 multiplied by 3.5. And the 3.5 that I have is 0.35. Just checking that is 0.35. Just checking that. All right. So our X bar, which means the mean of the mean of X. So it is 3.5 actually. It's actually 3.5. Very good that I found it on. So this is 3.5. So I'm going to multiply by 3.5. 3.5. Just to be careful. So I'm going to close parentheses. When I hit enter, what I will calculate is the y-intercept. So y-intercept is 6.6. Y-intercept B0 is 6.6. So I'm now ready to calculate the predicted equation. So the predicted equation actually, y hat is equal to B1, and B1 is 0.7 x plus B0. And B0, let me see where I wrote my answer for B0. Where did I write my answer for B0? And let me check it in my calculator. Did I write it down? What was my 6.6? Okay, just making sure. 6.6, that's all. This is the predicted equation calculated by hand. So the predicted equation calculated by hand is that analytically, they can actually ask you to calculate the equation analytically. All right, so at least it show all work. Alama gives you points for showing your work. So if you show all the work, you can get partial credit. Anyway, so that is about question. That's about that question that people dread for some reasons. So let's answer that part of the question. The other part of the question says, do a scatter plot. So I'm going to pull up that question again. And then this is the draw a scatter plot. This is A. We answered B first. Draw a scatter plot of the diagram. Comment on the type of relation that appears to exist between X and Y. Grab the least square regression line on the scatter plot. We already know how to do this. Anyway, but because it is review, we're going to do it again. So we're going to draw a scatter plot. We have calculated the equation, the predicted equation by hand. So now we are about to do a scatter plot. So we go to L1 and L2 and put it in the explanatory variable in L1 and response variable in L2. Okay, so I am going over here and clearing my main screen. I need it to be okay. And then I'll go to STAT, and then I'll clear L1, clear L2. All right, so now I cleared L1 and L2. So what I'm going to do is, what is in L1? What is my explanatory variable? The values of X. So I have 1, enter, 1, enter, 3, enter, 4, enter, 6, enter, 6, enter. All right, so the next now is go to my response variable, put it in L2, 5.1, enter, 6.5, enter, 5.3, enter, 3.6, enter, 2.2, and 2.4. Then the next one is eyeball my data. Eyeball the data and see that they look like what I am given. So there is no extraneous, nothing looks fishy there. All right. And they are on the same horizontal line. The next thing I want to do is put my mode in decimal places. I think it's in 1 decimal point now. I like it in 3 decimal places. So I'm going to put it to 3 decimal places. Unless I'm otherwise to, okay, I go back. Mode, arrow down, then arrow to the right, and put the mode to 3 decimal places. All right, so I have now told my calculator that I want 3 decimal places. So second quit. Then the next thing I want to do is turn the catalog, diagnostic on. Go to catalog and turn diagnostic on. If you haven't done it in a while, you want to do it once in a while. But I know I turned it on maybe 2 days ago. So, but I want to turn it on again. So go to diagnostic and make sure that diagnostic on is turned on. That way it can give me my coefficient of correlation and coefficient of determination. So I see diagnostic on, I select that, I hit enter. So I got done, it turned on. So now the next thing I want to do is do a scatter plot of the data in my L1 and L2. So I am going to go to second start plot, select plot 1. And then I want to do a scatter plot. It's already selected for me. Out of the 6 kinds of statistical plots, scatter plot is number 1. And by the way, I hope we know that the second one is line plot or time graph. The third one is histogram. The fourth one is a modified box plot for detecting outlier. The fifth one is ordinary box plot for getting the 5-number summary. And then the sixth one is a quantile plot, which I use in Unit 4 for also detecting outlier in your hypothesis testing. All right, but we don't need any of them but the first one, scatter plot. So we are done because scatter plot is turned on. So I have L1 and L2. So I want to do a scatter plot of what is in L1 and L2. But before I do that, I want to check my windows. Is there anything in my function? So I'm going to go to y equals. Is there anything? And then if there's this argument, I will just second quit. The argument comes out, I do second quit, and then I go to y equals. If there is any equation there, I better take it off. Clear? All right, so I'm ready to do zoom 9. By the way, before I do zoom 9, I make sure that only one plot is selected. If 2 plots are selected, it will give you quit. It will tell you to quit. Give you an argument. So only one plot should be selected. If 2 or 3 plots are selected, your calculator will not let you do the zoom plot. Okay, so we're ready to second quit right now, and we want to zoom 9, zoom statistics. So zoom 9 means zoom statistics. Anytime I zoom 9, I'm trying to tell my calculator to draw a statistical graph for me. So zoom 9, so I select, and I see that actually when I eyeball this scatter plot, I see that my scatter plot, the line of best fit will be a line with a negative slope. The line of best fit will be a line with a negative slope. Therefore, I'm expecting the coefficient of correlation to be negative also. Coefficient of correlation will be negative because the slope is negative. Therefore, relationship between the explanatory variable and response variable right now, it is high negative linear relationship. So I can already conclude that there is a high negative linear relationship between the given explanatory variable and response variable. And that's all I'm told to do. I can actually eyeball the options I'm given, and then an answer from there. I can already see that the correct answer is B. The correct answer, I could be told to put a line on it, so let me go ahead and put a line on it, even though I'm not asked to put a line on it. Okay, so I can go to start immediately, arrow to calc, and I'm not doing one variable start, I'm doing linear regression. Remember, there are two kinds of linear regression. I like the one that looks like slope-intercept form. All right, but you can actually use number 8, another linear regression, where the slope, the variables are interchanged. Doesn't really matter, but I like using 4. So I'm selecting number 4. And then my calculator is giving me some arguments. It's asking me, what is an L1? Is it your explanatory variable? Yes. Is your response variable in L2? Yes. Do you have frequency? No, I don't have frequency. And I don't need to type anything there. Do you like to store your equation in a function? Yes. I like to choose no function fy1. So I will tell my calculator to store the equation in y1. So vars, if I want to store it in y2, I say vars y vars function y1, because I want to store the equation in y1. If I want to store it in y2, I choose the function that I want. So I just want it in y1. So my equation will be stored in y1. Remember the things I've already told my calculator. I told my calculator that my equation should be to 3 decimal places. I also told my calculator to calculate the coefficient of correlation and coefficient of determination. Then I'll calculate. So if I hit calculate, and then it gives me everything that I want. First of all, it told me that it gave me an equation in slope-intercept form where the slope is negative 0.7. The coefficient of correlation, actually the y-intercept is 6.7, and then coefficient of determination, which is the square of the coefficient of correlation, is 88.6%, very high, and the coefficient of correlation is negative. Therefore, we want to remember that the slope, the sign of the slope and the sign of the coefficient of correlation must be the same. So there is a whopping 94.1% linear relationship between the explanatory variable and response variable. There's a high negative linear relationship between the explanatory variable and the response variable. All right, so let me see if they asked another question there. So we have answered this question number 4, which people don't even attempt. For some reason, some students skip it. Okay, choose the correct graph. Actually, we are told to graph the, okay, well, now we did. All right, so now if I push graph, the line that I stored in y1 will be on my graph. If I push trace and actually the equation will show up also. And then let me go and see which of them look like my line of best fit. All right, so my line of best fit actually looks like, I need to eyeball that graphic in so I can be sure. So the line of best fit actually is C. My line of best fit looks like C. Yeah, because the y-intercept is Actually, I mean, everything about C looks like marble. So I can make a decision